Hi, excited to be here. We'll talk now about really cool stuff about AR apps and how we can build it with React Native. But before we just jump into coding and how we'll build AR, let me just introduce myself. My name is Vladimir Novick. This is my new fancy logo. I'm an independent consultant, and I work in web, mobile, VR, AR, and IoT fields. Probably I should add AI and blockchain to be like on top of buzzwords, but I don't do anything on that side. So what we will be talking today, we will talk about we will start with the history of augmented reality, how we got to the point where we are at right now. We'll talk about the purpose of AR apps. We'll show some cool demos. And we'll talk about Vero React as one of the options for building AR apps. And we actually will talk about a little bit of science behind developing for AR and 3D in general. So what is augmented reality? So it's not like holograms like this, but it's more like having some sort of glasses, or having our devices, and basically an overlay, digital overlay on a physical world. It can get beyond beyond pictures. It can get to our senses, to haptic feedback, to various stuff. So how everything began, and yeah, the last one, we are not there yet. We're like on the third person, but eventually we will get to the last one in several years, I hope. So it started in the beginning of the last century when there was a novel called Character Marker, and then there was the first introduction of AR as a concept. 50 years later, the first machine was built where you need to put your head on inside, like it's a huge, like arcade machine that instead of a monitor, you just stick your head inside. It worked also for VR. At 68, there was Sword of Damocles, and it actually was the first head-mounted display with tracking. But it was so heavy, they had a crane to hang this stuff on your head. So if the crane breaks, you die. So at 82, there was AR for weather broadcasters. Well, till 90s, there was no such term as AR in general. There were all concepts, there were like ideas, but the actual term was born at 90s, and it was invented by Tom Codell. And then it just began the whole AR revolution. It started with like virtual fixtures. It's kind of a machine. You will see pictures in a bit, how it looks like. Then in 96, well, there is a concept of markers in AR. When you scan something like a marker of sorts, you have 3D model on top of this. So the idea of this and the first implementation of markers was born at 96. It was called cybercode. In 98, NASA developed their first AR dashboard for X38. 99, there was iTap wearable that served as a prototype and progressed later on to Google Glass in 2012. Commercial-wise, 2008, there was the first introduction of AR for commercial purposes by BMW. Before that, it was more research-oriented or like military, like for NASA and stuff like that. 2010 was Kinect. Then Google Glass, and right now, like recent years, like several years ago, there was Microsoft HoloLens. Who have seen Microsoft HoloLens demos? Nice. So probably half of you, a little bit more than half, saw these demos when you put this headset and you see the whole world changes, right? It's not actually as it looks like, but you actually can put holograms in the real world, like digital overlays. You remember the actual location of the hologram in the world. In the same year, Pokemon Go was released. And back then, Pokemon Go was just an image overlaid on the video without any perception of physical context. But still, the world gone crazy with the Pokemon Go, 45 million daily users. It was just crazy. At 2017, last year, that was a really breaking change for us, React Native developers. ARKit and ARCore was introduced by Apple and Google. And these frameworks gives us an ability to perceive our reality, our physical world, understand the surfaces, understand how it's structured, and put things on surfaces. We can actually apply physics on these surfaces. For instance, I can have a 3D ball jump on this table because I know that this is a physical table, this is a surface. And right now, we're waiting for these wearables, we're waiting for Magic Leap glasses, we're waiting for like lots of new stuff. We will see where it goes. And if we talk about old stuff, that's how it looked like. So the first one is Sensorama, Sword of Damocles, and you see it can collapse the whole ceiling on the guy. So I want to try that. I don't know. And then this is the dashboard thing and the markers, fixtures. And yeah, this is the Google Glass prototype. Yeah, it just, I don't know. So, remember like 20 years ago, yeah, don't sit near your TV. Yeah, right now we have it on our faces, and yeah, everything is fine, right? Yeah, and we get to the point then when 30 years old talk about love of their life, and we're searching for Pokemons. Makes sense. So the main question is why AR? Well, not only because we want like our paintings to react to stuff that we do. Actually, there are lots of applications for AR. We can use it in retail. It's actually really successful in retail. We can preview products. We can get deals based on physical markers. Walking in the store, we can see a deal for like 50% off on something or stuff like that. We can get additional info on products. We can share products images. We are all social right now. We have like a bunch of social experiences, social apps, social networks. So we can share this 3D object, these models in the real world with our friends and eventually make them like buy this product. So yeah, it's all about ads in the end, right? We have AR games. Which are really cool because you interact with the digital world, but you can use the physical environment. It's much more addictive because you don't perceive it as you're into the game near your computer or headset or whatever. You in the real world, and you have like these digital characters, monsters, or whatever, and you just interact with them. Social sharing again, and you can explore physical world with digital overlay. Well, it can get really problematic. We all knew those things that went with Pokemon Go, and people got into different places they're not supposed to go into and got injured. So we need to be like careful about that too. So AR is used already for manufacturing. We can get valuable information on the detail of machine we're building without any distraction. Instead of looking at the code of the machine and looking at the manual how it's supposed to look like, we can get the 3D model of machine part and interact with it. We can get instructional videos. If we didn't do our homework and we are bad technicians, we can just like, okay, let me just check how it works. We can use various set of tools. Right now, for example, you can download apps which lets you just measure your room. So you want to know dimensions of your room, you can just measure it with AR. Location-based AR is really popular. You walk on the street, you just open your phone, you look at the sign, and you see like some info or like if a restaurant nearby, stuff like that. And again, you can get information based on physical context. You can display various markers for location info and data, and eventually it helps users and again ads. So yeah, at some point you remember the picture with the like history of AR and the guy walking with the glasses. We all will be walking with the glasses between hanging out their heads. So the question and the main purpose of the talk, how we can get started with React Native with AR and React Native. So there are various libraries for AR that leverages AR and the ARCore. There are wrappers, but they kind of a little bit experimental. Some of them, like React Native ARCore is a little bit experimental. React Native ARKit does support everything. There is Unity 3D and Unreal gaming engines. Makes sense to create AR games with like heavy lifting, like 3D model interaction there, but we want to create apps, right? So we had about React 360. It was called React VR back then, but it's VR. It's not what we're looking for. And there's Vero React. And these guys did an amazing job, and they actually gold sponsor of this conference, and their booth is over there. So yeah, these guys. So what does Vero React gives you? We have real-world 3D tracking. We can detect plane surfaces. It has its own powerful native renderer that renders an image, and it leverages both AR and ARCore, so ARKit and ARCore. So you can use on both Android and iOS. You can recognize images, recognize markers. You can create various physical world, real-world effects. You can do physics, animations, particle effects, stuff like that. To get started with this, you simply go to the website, you install React Vero CLI. On the website, you get the API key, and you init your app. So the basic anatomy of the app looks like this. We have the AR scene. We have a bunch of components. We have the scene, we have the light, we have text hanging out there. We have plane selectors. We can select various planes. And let's see it in action, how it looks like. I hope it will work. Yeah, it always happens. It didn't work. Now I try to mirror this thing, so it's a cool app, but sometimes, yeah, now it worked. Okay, so I want to have AR experience, and whoa, I'm in the portal. No. Let me just walk on the stage. I try to scan surfaces on the stage, and you see I have a surface here. So let's put a monster on the stage. So yeah, this guy is here. You see his shadow is on the stage. So, and also it's kind of cold, right? Snow. So this is particle effects. In addition to that, let me try to find another surface. I can put this thing. No. Let's see if it will work. Lighting is the light's a bit off, but yeah, here's me just walking on the stage searching for stuff. So you understand, you understand why it can be complex for and can get awkward sometimes. I have a whole collection of people walking randomly on the stage, not on the stage, just like bumping into walls. But let me just reload the thing, and we'll try it again. Yeah, hello. And let's do another surface. Yeah, so this is a portal. And I hope I won't get stuck inside, but let's do it. Hey, hoppa. I'm in the portal. And here you see I have the real world up there. Yeah. Hey there. So I'll get back until it closes and leave me in the virtual world. And Let's scan another surface. And this is just dancing model. Yeah, oops, got through the portal, sorry. Better go around that, right? Yeah, I don't want to get stuck there. So you got the idea, it's cool, right? Now I need to find my mouse. Let's just close this thing. And yeah, after the talk, everything will be open source, so you can just check the code. So AR is cool, right? You understand why it's addictive. You can get stuck inside for like, if the portal closes, that's the end. You are there, you cannot get out. So let's talk about how it's built, right? Let's check this out. For example, the code I showed you, you probably have seen a bunch of like numbers here, and it looks a little bit weird-ish. So we're working with 3D. So we have coordinate system, and it's called right-handed coordinate system. Why it is, and you can just memorize the x's, y, and the x and z, but there is a better solution. Why it's right-handed? Because if you take right hand, you point it at yourself. This is y, this is x, this is z. Meaning, if I want to put something in front of me, I put it on minus z, and y and x respectively. So positive z behind the viewer. It's an important thing. Directions changed with applied rotation component. A rotation probe. So you apply rotation, you can get like minus 90 degrees on x-axis. To determine positive or negative rotation, like how do you know how we rotate? There's a thumb rule. So you just hold your hand like that, and this is the positive rotation. So coordinates are pretty much, we understood the coordinates, but we have lights and materials. And you've probably seen in the code there's ambient light. There are a bunch of other lights. And who have done 3D development ever? Nice. So for some of you, this will be like to recall like the basics of 3D development. For some of you, it will be new. So what is light and material? There are 4 types of light. There is ambient light, basically a light that surrounds us. Directional light, you can say sun is directional light. Point light, or for, the component is zero ambient light. For ambient, directional is zero directional light. For spotlight, there is zero spotlight component. And for point light is also called omni light. There is zero omni light component. So when you deal with 3D models, you need to light them up with these types of lights. And 3D models are not enough. We need textures. So textures, Vero supports different modes. Supports regular mode, it supports PBR modes, which is physical-based rendering. It's a little bit different concept, having more textures than and having an object looks more real, more realistic. But let's talk about the regular one. So we had that guy that danced over there. So his face looks weird here, because this is the diffuse texture. So it's flat textures that gives color and the whole like idea how the model will look like. And it's called diffuse texture. We have specular texture, which means it's basically how shiny an object is. And we have normal texture, normal map. Sometimes we have a mesh. When lights hit the mesh, we want to get that idea of depth of the model, but we don't want to create like complex model in 3D program. We want just, for example, we want to create cube and make it look like a brick wall. So we don't create each brick separately. We just apply regular diffuse map, diffuse texture, and apply normal map to give this idea of bumpy surface. 3D models in VRR, yeah, it's kind of combining memes in 3D without texture though. So you can get OBJ files, and you can specify what textures they use as PNGs. You can use VRX files, which are, for some of you that used 3D modeling and 3D development in general, sounds kind of familiar, because we know there is FBX format. So with VRX, you basically import FBX model that you can get from various places. And you basically transform this model by running this script. And you get your model with the textures. You can load it, and like monster, for example, like monster, but basically everything, like monster, the portal frame, and the dancing person over there. He also it was also modeled in FBX, transformed with VRX, and you've seen this on the stage. There is also a new format, GLTF, which is essentially it's a JSON file specifying materials and basic data. Then it links to bin file specifying things like animations, keyframes, stuff like that. And there is PNG part, which are textures. In terms of code, it looks like this. So we have zero ambient light. We specify the color. We can specify intensity. So ambient light comes from every direction, so we don't have directional information on the light itself. On directional light, we actually need to specify the direction where it comes from. So we see it comes from -1. And we have a bunch of those, like shadow orthographic position, and near Z, and far Z, and cast shadow true, stuff like that. So in lights component, we can specify various shadows parameters. And later on, if we put a quad, it's called Vero quad. It's basically a plane surface in the scene, and give it a probe to cast shadows, you will get the shadow of the model above this quad. So that's what you've seen with the monster. You've seen a shadow under the monster, right? So it was the quad reflecting the shadow from the light specified in the scene. With Spotlight, for example, you can define various angle properties like inner angle, outer angle, direction, and again, you see some shadow properties. So here, object, remember I told you about the textures? So here where it is. So I have the source for the Vero 3D object, which is monster VRX. Now, VRX specifies what images it will use, but I can also require them in resources to specify explicitly. I have this diffuse and this normal PNG. We also have a bunch of callbacks. We have on load end of the model, because I want to, for example, here, I had AR selector ref reset. Why I did that? Because when model was presented on the selected plane, I want the selection plane to reset and give me the ability to place another object and another object and another object. That's the quad I told you about. You see, you have AR shadow receiver. This probe basically gives you an ability to receive shadows. Well, it's self-descriptive, kind of. And quad also always vertical, so you need to transform it to -90 to be on the ground. In terms of material, we can also create materials. Now, with materials, we specify separately from our component. We call Vero materials.create materials. Also with animations, you can specify animations separately, or with tracking targets and markers. There are a set of APIs that you specify not inside the component itself, but outside, and then just use in the component. Like here, for example, I specify that I have ground material. Later on in my component, when I render something, I can specify that my material is ground, just passing a string, ground. And it will know that it needs to search through the materials directory of of an application and apply specified material. So we have various shyness props and diffuse color. Again, the regular color. Just treat it as just the color of this thing. And we have lighting model. So we have bling, which sounds kind of weird word. But actually there are 4 various lighting types. If you don't specify anything, it's constant light type. It's this over here. But you see how they are different. Like this is more glossy, kind of. This is like more matte. So you can specify material to be one of those lighting types. And with lights in general, you have various, like with Vero also, you can create VR things. So you can create like lighting environments, and you can go really beyond just the basic materials. Another important thing in AR is detecting planes. You've seen here I have kind of grayish surface that I clicked on, and the monster appeared, or the portal appeared. So I can do that myself, but there is a component that helps me with this thing. It's called Vero AR Plane Selector. It basically renders this gray box for me to being able to select the plane. And I have here like model array, and I have this guy here, Vero node. Vero node is you can treat it as like a view in React Native because it's kind of wraps the node you want to present in AR scene and AR world. So you also specify position. You can specify if you drag this thing around the world. You can do various stuff with this. In addition to plane selector, I have Vero AR plane component, which is much low level, and it doesn't give you the ability to like select, like to render this gray surface, but it gives you more. It gives you power to like select, to put things on AR planes and surfaces and stuff like that. Portals, right? Portals look really cool. So how we do this stuff in Vero React, we deal with various things. So first of all, we have Vero portal scene. Basically, it's a wrapper component. It wraps the whole thing. It's the whole thing. It's the doorway. It's the image beyond the doorway. It's like everything, the behavior, everything. So inside of Vero portal scene, there is a portal, and there's 360 image. Because with Vero React, you can also do 3D, and this 360 image, this is basically, sorry, you can do VR. With 360 image is basically this VR world beyond the portal, right? The Vero portal, the Vero 3D object is basically a 3D object for the doorway. And the portal component knows when to render which camera on the doorway to show this 360 image or to show the real world camera and stuff like that. So, in addition to that, you've seen snow, right? So there was snow coming from the, we don't have sky, but coming from the ceiling. And it's basically particles. So we can do snow, we can do fire, we can do like lots of things. We can do fireworks, we can do lots of stuff with particles. We can do smoke, like anything you can imagine of that comes in large quantities, spawns, like images that spawns from direction, get some form and shape, and then disappears. And to do that, we use Vero particle emitter. We position it as regular 3D model with just position, and we have various props on the emitter. We have the duration, how much time will take to spawn the whole thing, and like if we want to loop, we just specify we want to loop. We have the image that we want to create every time, like for every particle. So here we have particle snow for every tiny particle of snow that is spawned from this emitter. And you can define the spawn behavior. we see that there is some kind of lifetime of these particles, and we see the emission rate. So we can configure that to be like more snow, less snow. It can be with the shape. You see the shape here is a box, and it's above, so that's why you see everything is just going in the box down. But we can define it as fireworks. It will be sphere, and it will go outside, stuff like that. Image prop, we just put here, image prop. So the last question, last thing that, actually the first thing people ask me about AR and like VR in general, where do I get 3D stuff? Like, I don't want to go like to some website and just buy, like, spend huge amount of money of hiring like 3D modeler, stuff like that. Don't get me wrong, it's 3D modeler will always be better for the long-term project, but we want to like play around with things, right? So where do I get stuff? So you can get things from Unity Asset Store, which is really cool for, there is Unity 3D game engine, and it has Asset Store. You can get, let's say, for $30, you can get like the whole model with animation and stuff. So it will probably take much more for the 3D modeler to create this in terms of time and pricing and stuff. But we still need to open these models in 3D program, optimize them for real time. With Vero, not only Vero, with the AR in general, we can, it's the phone, we cannot render like 3D models with huge amount of polygons, really heavy stuff. We cannot render on the phone. It will probably render, but it will be performance-wise, it will just kill your battery, it won't work properly, it will be laggy and stuff like that. So we need to search for models that are real-time optimized, and they are low polygon, and it's a general rule for developing for mobile phone with 3D. We can, of course, go to TurboSquid. We can search for free models. We can buy models there. We can like basically search for stuff there. On Sketchfab, there's another site we can go. Mixamo. Mixamo is a really cool project by Adobe. And actually, my models were from Mixamo. This is a website you go to, you log in with your Adobe account. And you can choose from set of pre-made characters and both models from this set of characters. And it has lots and lots of animations there. So you can just download models from there. And actually, they work with Vero perfectly. You don't need to optimize anything. So just go there, grab models, put in your app, and just play around with them. Also, it's a really cool website if you just downloaded a model and you want to do an animation. So when you animate 3D stuff, you have sort of 3D rig on the model. So you need to define where a joint of like bones and stuff like that. So with Mixamo, you can do it automatically and apply animations that are out there. So it really speeds up the process. You, of course, can model in Blender, and maybe it sounds like tedious and like we are not 3D modelers, right? At least most of us. And why should we like model in Blender? But as I've told you before, if you take just a cube and you apply premium textures on this cube, you may get to the level of like really good 3D model with low level of polygons and really optimized for mobile. And these textures you can get from various websites I wrote here. And we can get from Substance Source, which is another cool program for painting on 3D. And it has like a Substance Painter, but you can get from Substance Source. It's like a library of premium textures. So the question is when to develop AR apps with Vero. I would say if you want to develop an app, do it with Vero. If you want to develop a game, like the full-blown game with like lots of interaction with 3D models and particles and stuff, and it's not connected to an app in any way, then probably you should go with Unity or Unreal engines like for games, dedicated for games. But most of apps can be built with Vero, and actually, like, you can take any app, and you probably can think of AR experience that you can add to like any app, and it will make your app cooler. Let's just take for an instance, like change your React app, right? So there's an AR feature there. If you haven't tried, you should try. It's actually created with Vero, and it's open source, so you can search this. You can go to GitHub, you can get this code, you can look how it looks like, and the same components I showed you here during the talk. So it makes your app really cool, and you can actually get really exciting features in the app, like previewing products and stuff like that. Go out and start building AR apps with React Native and Vero today, or tomorrow, or whenever you have time for that. Yeah, but you definitely should try it, and thanks a lot. It was really a pleasure speaking here, and yeah, thanks.